Buckle up, space explorers. In early 2024, astronomers using Gaia mission data made an out-of-this-world discovery just a stone's throw away from us. About 2,000 light-years, a massive stellar black hole had been hiding in plain sight, and trust me, it's the heavyweight champion of its kind. This cosmic giant tips the scales at a whopping 33 times the mass of our very own Sun, claiming the title of the heaviest stellar black hole ever found within our Milky Way. Meet Gaia BH3, a black hole so massive, it's breaking the rules. Its mind-boggling 33 solar masses should make it an ancient relic from the early universe's low-metal environments. You know, places that haven't been enriched by the recycled matter of exploded stars. But nope, this heavyweight is chilling in our galaxy, cozied up to a dying star like it's just another neighborhood watch member. Here's the kicker: Gaia BH3 isn't putting on a show, no flashy accretion disk, no X-ray explosions. It's just a stealthy black hole, blending into the background like a master ninja. This is wild, because our current understanding of how massive stars go out with a bang doesn't account for this quiet giant. Maybe it's time to rethink what we know about stellar demise. It looks like our models need an upgrade. Or perhaps this ancient heavyweight isn't just a relic. It's a messenger from a time long past, slipping under our radar until now. This find isn't just about an invisible cosmic giant, it's about rewriting the rulebook on how we think the universe works. And trust me, we've been getting a lot of these unexpected messages lately, from our own solar system to far-off galaxies, and even the behavior of the universe itself. Each one nudging us closer to understanding just how little we know. Mars, the planet that once stole our hearts with its Earth-like promise, only to leave us feeling let down by its barren, red landscape, a world where water flowed long ago, but now lies dormant. We thought we'd close the book on Mars, deeming it a dead, dry, and ancient planet silenced for billions of years. But just like an old, worn-out page in a book, new evidence is slowly unfolding a different chapter. In 2024, groundbreaking data from radar readings and seismic measurements gathered by both lander robots and orbiting spacecraft began to hint at a hidden narrative, one that suggests Mars may not be as lifeless as we thought. Imagine a Martian world hidden beneath its rusty red surface, an enormous, kilometer-deep secret waiting to be uncovered. Radar readings and seismic shocks are painting a stunning picture: massive underground reservoirs, possibly holding entire oceans of water. It's mind-boggling to think about how these ancient waters may have surged through the planet's crust as it was drying out, leaving behind the barren landscape we see today. This game-changing discovery flips our understanding on its head, and trust us, this is just the beginning. The revelation that water may be lurking beneath Mars' surface has profound implications. It means our red planet neighbor has experienced internal activity way more recently than we previously thought. This raises an intriguing possibility: conditions might have been stable enough to preserve microbial life for millions of years, and it's not just in the past. I know some scientists are keeping a close eye on the idea that liquid carbon dioxide could be hiding beneath the surface instead. While that'd be a blow to potential life as we know it, either way, Mars is turning out to be far from the barren, fossilized world we once pictured. This discovery is sending shockwaves through our understanding of planetary life cycles, and we're just beginning to scratch the surface. With thousands of exoplanets waiting to be explored, we've been classifying them based on atmospheric makeups, temperatures, and distances. But what if our filing system is built on assumptions that are totally off the mark? What if beneath some of these dead worlds, there's actually a treasure trove of life giving potential just waiting to be uncovered? Mars' own hidden water reserves have us rethinking our theories, so who knows what other surprises await us elsewhere in the galaxy, especially among those distant planets that seem frozen and lifeless from afar. Get ready to turn your understanding of space-time upside down, because astrophysicist Daniel Weiland and his team dropped a mind-blowing theory in 2025. They found that planetesimals, or the tiny rocks that build planets, could have started forming just 200 million years after the Big Bang. That means there was potentially enough going on for liquid water to exist on these early rocky worlds. It's not as far-fetched as you'd think. In cosmic terms, those first terrestrial planets popped up almost instantly. Once atoms could even form in the universe's cool-down process. So, what if life didn't start super late in Earth's history? What if it was a near-universal occurrence that we just haven't discovered yet? The cosmic timeline is getting rewritten big time. Whelan's team shook things up with their research, showing us planetesimals started forming hundreds of millions of years earlier than we thought. That's a major game changer. We used to believe rocky planets needed generations of stars to create the right stuff for life. But now, it seems like even in those super early days after the Big Bang, when the first stars were fading out, the building blocks of our world were already taking shape. That means we might be looking at a universe where microorganisms could have gotten their start way earlier than we imagined. And another recent discovery just cranks up the odds for this possibility even more. Get this, astronomers using the James Webb Space Telescope just made an out-of-this-world discovery in JADIS GSC 140, the most distant galaxy observed so far. They found oxygen galore, which is a huge shock because it means this ancient galaxy had already lived through one complete star-making and star-dying cycle. We're talking 300 million years after the Big Bang. Talk about setting the universe's pace way faster than we thought. This blows past our expectations for when complex chemistry could have kicked in, leaving us with a pretty mind-blowing question: what if life didn't wait for Earth? What if we're not the start of the story, but rather just one page in an epic cosmic novel? It's a thought-provoking idea that raises the classic "where is everybody?" question. If life sprouted up as early as 13.5 billion years ago, and given enough time, you could have colonized the whole observable universe, not once, not twice, but 5 times over, then where are all those extraterrestrial neighbors? But what if our cosmic neighbors didn't vanish due to a lack of space or resources? What if something much creepier was at play? Enter the James Webb Space Telescope, the new kid on the block that's giving us an unprecedented look into the cosmos. Since its debut, astronomers have been poring over its stunning images from the deep universe, and they stumbled upon some eerie guests. Hundreds of tiny specks scattered across these far-off scenes. At first, they seemed like a rare, obscure phenomenon, but it turns out they kept showing up again and again, and now we're left wondering, who or what are they? Get ready for some serious cosmic creepiness. The little red dots have astronomers scratching their heads and whispering among themselves. These tiny objects just won't add up to anything we've seen before. Don't let their cute nickname fool you, though these are not your average galaxies. We're talking about teeny tiny worlds measuring between 150 to 500 light-years across. That's dwarfed by our own Milky Way. Now, if they weren't shining so bright, you'd hardly notice them lurking in the shadows of space. But here's where it gets really spooky. It seems these little red dots might actually be supermassive black holes actively feeding on matter and growing stronger by the second. Yes, you just read that right. We're talking about cosmic monsters right before our eyes. Fast forward 600 million years after the Big Bang, and we're living in an era when these mysterious little red dots start popping up everywhere. Now, you'd think these cosmic objects would light up like a typical quasar, but nope, they remain stubbornly X-ray free. And if they were just tiny proto-galaxies on steroids, packed with bright stars, that wouldn't make sense either. Why would we see the same weird stellar spheres hundreds of times all around us? According to our current understanding, little red dots shouldn't even exist. But there they are, staring back at us like cosmic puzzles waiting to be solved. What's going on here? Is our knowledge of the universe just not cool enough to comprehend these little enigmas? The mystery deepens. Wait, it gets even more mind-blowing. Little red dots weren't just hanging out, they actually vanished after the first billion years. But what if their brief existence was so intense, it wiped out early life forms, setting back evolution by millions of years? One theory takes a dark turn. However, recent studies have turned the tables. These cosmic oddballs might not be extinction-level threats at all, but rather an unusual type of quasar. Imagine a thick, dense cocoon made of gas and dust. That's what we're seeing. And what's hiding in the center? A supermassive black hole on the hunt for its next meal. Hold up, though. This quasar explanation doesn't account for where all these cosmic cocoons came from or why they vanished into thin air. So, let's drop the business as usual act and own up to it. Our early universe models are pretty shaky ground. But just as we're about to scratch that surface, one of these little red dots throws us another curveball. Meet JADES GSZ 131. At first glance, it looks like your average tiny galaxy. Discovered by the James Webb Space Telescope, this little guy is one of the brightest and earliest compact galaxies we've found. But here's where things get really bizarre. It's emitting something called Lyman alpha radiation. A totally unexpected twist that leaves us wondering what other secrets these mysterious objects still hold. Now here's where things get wild. Lyman alpha radiation is like a signature tune from young, sizzling stars. You'd expect that, but there's a catch. During this galaxy's time, just a few 100 million years after the Big Bang, our universe was totally different. It was shrouded in a thick cosmic fog of neutral hydrogen. This stuff would have absorbed and scattered light like Lyman alpha radiation, making it invisible to us. According to our models, that radiation should have gotten lost in this early universe haze, but somehow it's managing to break through, a total head-scratcher. But here's where things get even more mind-blowing. This Lyman alpha break isn't just a one-off. We see the same effect in every galaxy from that era. Yet, this tiny galaxy we're exploring is beaming its signal across the universe like it's got a superpower. It's as if the cosmic fog never existed for this little guy. This totally disrupts our current understanding of the universe's history, something called reionization. We thought it was a gradual process that took hundreds of millions of years, with the first stars and galaxies slowly ionizing the hydrogen mist, allowing light to travel freely. But if we've got galaxies breaking through this barrier like Jade's GSE 13-1, then either reionization started way sooner than we believed, or it didn't happen uniformly across the universe. Talk about rewriting the cosmic script. So, imagine the universe's transition from foggy to clear wasn't a smooth, gradual reveal. Instead, it was like spotlights bursting through a storm, patchy, chaotic, and intense. This new idea, called chaotic reionization, flips our understanding on its head and leaves cosmologists scrambling to rewrite their models. But just when we thought things couldn't get more dramatic, something else threw everything off balance. Literally, the very fabric of space-time itself wasn't what it seemed. In 2025, an epic discovery shook our understanding of the cosmos when researchers behind the Dark Energy Spectroscopic Instrument, DEC, unveiled the largest ever 3D map of our universe, and it came with a major plot twist. For decades, we've been riding the dark energy wave, thinking it was this steady, unchanging force driving galaxies apart at an accelerating pace. Einstein's cosmological constant, or lambda, was our guiding light, representing a fixed cosmic pressure in the vacuum of space. But as DEC's data came to life, something caught their attention, and it wasn't what they expected. Across vast distances, galaxies were arranged in a pattern that didn't quite fit the predictions, leaving us wondering if we've been wrong about dark energy all along. Here's the rewritten paragraph. Imagine cosmic sound waves that date back to the dawn of time. This phenomenon's called baryon acoustic oscillations, or simply ancient ripples in space. As matter clumped together, these patterns left behind a fingerprint in the universe's large-scale structure, dense spots with more galaxies. But here's where things get wild. When DECI researchers dug into their 3D map data, they found that these galaxy rings were bigger than expected though. And this means dark energy was an overachiever back in the day. If true, it blows a hole in our current understanding of lambda, Einstein's mysterious constant. Our go-to cosmological model, lambda CDM, relies on dark energy being steady and predictable, but DECI's findings suggest that might not be the case after all. Get ready for a mind-blowing alternative. What if dark energy isn't just another mysterious force in our universe? It's possible that its power has been growing over time, maybe due to an interaction between gravity and something we haven't discovered yet. Or, take a deep breath, because the most radical idea is this: what if dark energy isn't even part of our universe at all? Maybe it's a symptom of our own cosmic neighborhood, being just one bubble in a multiverse, where different regions have their own unique versions of physics. The possibilities are endless and will keep us on the edge as scientists continue to unravel the secrets of dark energy. Buckle up, folks. Scientists are proposing a game-changing concept. Space itself is like a living, breathing entity that goes through transformations. Think of it like water freezing, boiling, or anything in between. Right now, we're witnessing this cosmic evolution at an incredibly slow pace. This idea challenges the very foundations of our understanding, as standard physics might not be enough to explain what's happening. But here's a surprising twist. If this theory pans out, dark energy's slowing growth would actually prevent the universe from experiencing the Big Rip. a catastrophic event that could shatter stars and planets into pieces. So, while we're venturing into uncharted territory, there's reason to breathe a sigh of relief. You think that's all, folks? Think again. The universe might just have another trick up its sleeve. It could potentially collapse back into a singularity, setting the stage for an entirely new Big Bang. But let's not get too ahead of ourselves. We've got 1 trillion years or so to wait and see how this plays out. Meanwhile, another mind-blowing discovery is shaking things up in the world of cosmology. Get ready to have your assumptions shattered. In 2025, astrophysicist Lear Shamir dropped some major science using James Webb Space Telescope data from its advanced Deep Extragalactic Survey, and what he found seriously challenges a long-held cosmic truth. What could it be? Keep watching to find out. Buckle up, everyone. The cosmos just got a whole lot more fascinating. According to Lear Shamir's groundbreaking study using James Webb Space Telescope data, it looks like our universe might actually be spinning big time. He peered into the past at over 260 ancient spiral galaxies, and what he found will blow your mind. Instead of a 50-50 split between clockwise and counterclockwise rotations, a whopping 2/3 of these far-off galaxies were spinning in the same direction, clockwise. This is major news because it challenges our understanding of an isotropic universe, one that's supposed to be all about equal parts in every direction. But it seems we might have just found evidence that our universe has a hidden twist, and I'm not talking about black holes. Get ready for a paradigm shift. The discovery that 2/3 of ancient spiral galaxies in Shamir's study are spinning clockwise has huge implications. It basically upends our understanding of the cosmos. This staggering imbalance hints at something much bigger, a directional axis across our observable universe, which means the entire universe might actually be rotating as one big unit. And here's the kicker. This finding puts a major dent in the cosmological principle, the bedrock of modern cosmology that assumes the universe is homogeneous and fair game from any direction. Think about it, if our universe has a preferred rotation, does that mean there are other hidden patterns waiting to be uncovered? The mystery just got a whole lot more intriguing. The cosmological principle is more than just an idea. It's a blueprint for our universe's grand design. It says every place and direction in the cosmos is equal, with no standout spot or special alignment. But now, picture this: if our universe does indeed have a rotation axis, that changes everything. It would warp space-time itself, influencing how light moves, galaxies orbit, and even time ticks along. We'd need to rethink our understanding of these fundamental forces, because, let's face it, we've been operating under the assumption that a rotating universe just wasn't possible. And here's where things get really fascinating. This cosmic rotation might be the missing piece we needed to explain away dark energy's mysterious fluctuations. Could it be the key to finally cracking one of cosmology's biggest enigmas? Imagine scientists poring over data from massive projects like the DSI survey, trying to make sense of dark energy's seemingly erratic behavior. Now, what if we told you that this cosmic rotation could actually be skewing our view of the universe? It sounds far-fetched, but consider this: a spinning universe would give us a different perspective on the very data we're using to study it. It might even make dark energy appear more unstable than it truly is. This revolutionary idea already seems to fit with what we know so far, and here's the mind-blowing part: our universe could have been spinning all along, and we just didn't catch on yet. Let's dive deeper. What actually got our cosmos spinning in the first place? If Lear Shamir's groundbreaking findings hold up, one jaw-dropping explanation could be that we're living inside a massive black hole. This concept is known as black hole cosmology and was once just an intriguing thought. Think about this: if you were to squeeze all of the observable universe's matter into a single black hole, it'd match the exact size of our observable universe. Talk about cosmic synchronicity. Now that we've explored this mind-bending idea, it's time to see if we should take it more seriously. You see, all the black holes were familiar with our spinning, and guess what?